hard to do selfies with a big tree like this. No, it's perfect. It's perfect.
Yeah.
On the photo. Phoenix is gonna come back to live. He's always good. That's true.
I've played programs about mycorrhizal fungi networks, and this here in the like this is a bear. If it's you feel like it's coming towards you, or if it's on trail. Other than that, though, just leave the bears alone, and they'll leave you alone for the most part. Thank you. And one last thing, these fences are here for a reason. They're to keep you on this side of the fence, to protect the vegetation, to protect the soil. The reason we have these fences, so we can protect these trees that we all came here to see. So, I assume that we all came here to see the giant sequoia trees, right? That's hence the name Sequoia National Park. And we're standing in front of the biggest tree in the world right now, the General Sherman Tree. Pretty cool. And in my talk, I'm going to be talking about how these trees got a lot of help from a very small friend. Before I do that, we're going to talk about the biggest tree in the world. What does it mean to be the biggest tree in the world? So, like I mentioned, the General Sherman Tree is the largest tree on Earth, but it is not the tallest tree on Earth. Does anyone know what the tallest tree on Earth is? Yes? No? Like even the species, maybe? Have a guess?
Pine something.
That's a good guess. No, it's not. It's not a pine tree. They're very similar to sequoia trees. They also have a national park named after them. Yeah, redwoods. So redwood trees are the tallest trees in the world. And because you didn't know the species of the tallest tree in the world, I'm going to assume you don't know the name of the tallest tree in the world, so I'll just say it. Hyperion is the name of the tallest tree in the world. It is 380 feet. About 100 feet taller than the General Sherman Tree. So the Sherman Tree is only 274 about. So very, very tall trees over in Redwood National Park. And they are related to sequoia trees. They're both a kind of cypress tree. They both have that red wood, hence the name. But redwood trees are a lot skinnier and they need a very different kind of environment to survive than a sequoia tree. That's why there are no coastal redwood trees here and there are no sequoia trees over at Redwood National Park because they just have very different things that they need. But yeah, the redwood trees are the tallest trees in the world and the General Sherman Tree is not. So if it's not the tallest tree in the world, but it's the biggest, what could make it the biggest?
The girth?
Yeah, exactly. So like the width. So sequoia trees are in general the widest trees on Earth, but the General Sherman Tree isn't even the widest tree in the world. The General Grant Tree is wider than it, and so is the Buhl Tree and other unnamed sequoia trees. So it's not the tallest and it's not the widest, but it's still the biggest. So how? Biggest by... There's one other factor. By volume, yeah, by volume, yeah. So just based on how many things you can put into it. So given the General Sherman Tree's height and width, that added up together makes it the biggest tree in the world. And I like standing next to this sign because there's a really, I mean, it has a lot of good information on it. But there's a funny fact on here that tells you how many bathtubs can fit inside of the General Sherman Tree, which I think is a really silly number to measure things by. But if you were curious how many bathtubs can fit inside the Sherman Tree, it's 9,844 baths. So that's a lot of bathtubs. I didn't know I needed that information before, but now everybody knows. In case you're ever doing a bath-related math problem in the future, this will be very helpful, I'm sure. So it's not the tallest, not the biggest, or not the widest, but it's the biggest tree in the world by volume. But it didn't get that big all by itself, or, oh, actually, before I say that. So the sequoia trees start out as a pretty small cone. This is a sequoia cone. This is kind of a bigger sequoia cone, but they're about the size of an egg. You'll see them laying all around here. And this one cone can hold over 200 seeds, just in this one thing. And the Sherman Tree came from one of these seeds, and I have when I picked this cone up, a seed fell out of it, so that's very lucky because they're hard to come by this time of year. But this is a sequoia seed. You probably can't see it depending on how far away you're standing, but it's smaller than oatmeal. If you wanted to come over here and, oh goodness, okay. If you wanted to come over here and look at it, oh, there are actually two right here, so you can take a look at them and pick them up if you wanted to. But yeah, a tree this big starts as a really, really tiny seed, and there's something even smaller underneath our feet right now that helps all the sequoia trees in the forest grow, and almost all the other plants in the forest grow, and that's something really cool called mycorrhizal fungi. Has anyone heard of that before? No, seeing not a lot of recognition. Okay, some people know, some people know. Well, if you know, you can leave. Program over. Just kidding, stay. Hear what I have to say about it. So mycorrhizal fungi is really cool. It's a type of fungus, obviously, that grows underneath the surface of the earth, and it attaches to almost every single plant in the forest. So sequoia trees, pine trees, lots of shrubs and ferns, and basically what it does is it attaches to their root system, it colonizes their root system, and creates a symbiotic relationship between the fungus and the plant. Symbiotic meaning that they both benefit from this relationship, right? So the tree gets a lot, or the plant gets a lot of stuff out of it. You can imagine how big the General Sherman Tree's root system is, right? So the purpose of a root system is to give the tree like water and nutrients like phosphorus and nitrogen, and especially a sequoia tree has a huge root system, so it can suck up a lot of water. Its roots are about 100 to 200 feet in any direction for mature sequoia trees, so they can't go very deep, but they go very, very wide, and their width can be as big as the width of their branches, so sometimes up to 7 feet in diameter. So huge roots underneath our feet, which can soak up a lot of water for them. Sequoias need about 800 gallons of water a day to survive. But they're soaking up a lot of water, but there's a lot of wasted water in between these root systems of a sequoia tree and other plants. Because they are so big, they can't get into these smaller pockets of earth that are around. And so what the mycorrhizal fungi does is it basically creates a net around the root system and can get into these tiny little pockets of soil in between soil particles to pick up water and phosphorus and nitrogen that the plant wouldn't be able to access otherwise. And I have a picture of this. So here's a plant with this mycorrhizal fungi network all around the bottom. So it's this really like small white stringy stuff. So if you took a shovel and dug kind of anywhere on the ground around here, you might be able to see these tiny little white lines all around. And this is that fungi that's helping all these plants. And not only does it soak up the water and the phosphorus and the nitrogen to help the plants grow, but it also creates a cap on the plant's root tip, and it's like a shield, and it protects the plant from pathogens and other kinds of diseases. So it can do lots of different things, but like I mentioned, it's a symbiotic relationship, so the fungi also gets a lot from this relationship with the plant. And what the fungus gets out of it is that it's a fungus, so it's not a plant, it doesn't photosynthesize. It can't get any energy from the sun all by itself, right? So it needs the plant to get that energy from the sun. The plant can photosynthesize, and it will bring all of that good energy, those simple sugars and vitamins, all the way down through the root system and into the fungus. And that is the only way that mycorrhizal fungi can survive. If it wasn't attached to a plant's root system, it wouldn't be able to survive at all. So it really needs the plant to survive, and the plant really needs the fungus to be competitive in the forest landscape. Another really cool thing that the fungus fungus does is, you may have seen a fungus's fruiting body around the forest, also known as a mushroom. So mushrooms can, their main purpose for the fungus is to spread the spores of the fungus so they can continue to regrow and repopulate the forest. But it also can be a really tasty snack for a lot of animals in the forest, like chipmunks and squirrels and bears and deer and people. So if you've ever been mushroom foraging, you can thank mycorrhizal fungi networks for your tasty mushrooms that you've picked up along the way, which is really cool. And it has been shown that not only is this a good treat for a lot of people in the forest, people and animals, but also it helps, mycorrhizal fungi networks help forests rebuild after a disturbance. So we're in California, right? Pretty hot, dry place. There's a lot of forest fires here. Fires are common in this ecosystem, but they still need help after a fire comes through to regrow, and these mycorrhizal fungi networks are a huge help with that. There have been studies in Oregon and California to show that after disturbances like a fire, that mycorrhizal fungi networks are very beneficial to the forest regrowth. And there have also been studies on redwood trees, remember the cousin of the sequoia tree that live on the coast. These redwood trees were separated into two groups, one that were given mycorrhizal fungi on their root system and some that were not. And the ones that had the fungus on their roots were 2 to 3 times larger than the ones without. And that's just that one factor of this fungal network beneath the ground helping these trees grow. So that shows you how important just this one thing is. And one of my favorite facts about mycorrhizal fungi is that it helps the trees and the plants communicate with each other. So these networks are all connected underground, right? And so all the trees are using these fungal networks to talk to each other, basically, to tell each other if there's maybe a bug in the area, like suck up more water, there's a bug here, you need to build up your defenses, or if there's like a fire coming through. They can also use it after a tree dies. It will use these fungal networks to send its nutrients to other plants in the forest, and not just plants of its own species, but all the species of plants in the forest that are connected to these fungal networks will be able to communicate with any other type of plant. So it's like the internet, but for plants, and they're all talking to each other all the time. So very cool, really important part of the forest. But mycorrhizal fungi networks are very aerobic. Aerobic meaning that they need a lot of oxygen to survive. And that oxygen is stored in between like little pockets of air in the soil, just beneath our feet right now. And every time we walk on the soil, or we're driving, maybe parking somewhere on a dirt patch, we are compressing the soil, and we're removing those air pockets and removing the oxygen from the soil, so this fungus is no longer able to survive if we're walking in the same place over and over again. So not only are we killing the vegetation above ground when we're walking on it, but also these fungal networks below ground, which is why, again, it's so important to remember to stay on this side of the fence and to stay on trails. On other trails, it's not such a big deal if you want to go up to a sequoia tree and touch it, like that's totally fine. But in a place that's as populated, as popular as the General Sherman Tree and the Grant Tree, and say in Kings Canyon, where hundreds of people are coming to the same place every single day, if we were all walking right up to the Sherman Tree, that would be causing a lot of damage to its root system and the other plants that grow in this area. So it's really important that we're very mindful about how we're interacting with the natural world around us, where we're walking, and trying to stay on trail as much as possible so we can protect these amazing trees that we all came here to see, and that we all want other people to be able to come to see in the future. And just this one fungal network, this really tiny thing beneath our feet right now, everywhere across the forest, it's so small, but it helps one of the biggest plants in the world grow to be really huge. And just like it is very small and it can have a huge impact, you too can have a huge impact on the world around you, and especially here at Sequoia National Park. So I hope everyone continues to think about that as they go about the rest of their day here at the park. But thank you so much for coming to my talk. If you have any questions about anything, either my program or anything else, I'll be sticking around for like 15 minutes, so I'd be happy to answer anything for you. Thank you. Have a nice day. And yeah, you can come and look at, if you wanted to look at the sequoia seeds there. They're right here. They're very, very tiny. Yeah, it was. So,